Hello, 7th grade. This is our Unit 3 test review over chemistry. We're going to cover counting atoms, organic chemistry, physical and chemical changes, and a quick review over parts of the atom and the periodic table. Let's get started. Please get out your test review, and you can watch and fill out at the same time. Starting with physical and chemical changes. When there is a physical change says there are no new substances, and it keeps its own properties. A chemical change shows that there is a new substance created, and it will lose the properties that it started with. So let's talk about some items that we're going to classify as chemical or a physical change. First, we have ice melting. That is going to be a physical property because as the ice melts, it's still water and it still can be frozen back to ice again. The next example I have for you is coloring the water with food dye. If I use food dye into water, I still have water. It's now just colored water. And I did expect the color change because I put the dye in the water. The next example I have for you is a roasted marshmallow. You're familiar with this from lab. And this would be a chemical change because as you notice, you have a burnt area. This is a new substance created. It did lose the properties of the marshmallow, so it is a chemical change. Next I have a popsicle melting. Again, would be physical. I could refreeze the popsicle back and still retain its properties. And egg frying. Although this is still an egg, I cannot get the egg back to the way it used to be. So it is a chemical change. Alka-Seltzer fizzing. Alka-Seltzer is a tablet, and what's been given off in this Alka-Seltzer reaction are bubbles. And bubbles are an example or an evidence of a gas created. So the gas created makes it a chemical change because that is a new substance. Next I have fire, wood burning. Again, that is chemical because we have a new substance created. We have heat and light as well as smoke and ash. The wood cannot get back its properties. It has lost all properties it had to begin with. We move from the states of matter in this example. As I go from ice as a solid to water as a liquid to vapor, although I changed and possibly changed size, I did not lose any properties of the water. It is still water. Next, I have sugar dissolving. Sugar dissolving in this example shows that the sugar goes into the water and it makes a solution of sugar water. This would stay as a physical property because it is still water, it has sugar added to it, and I could evaporate the water out and leave the sugar behind. It did not lose any of its properties, and there was no new substance created. Lastly, I have bananas rotting. These bananas are decaying, therefore they're losing their properties. That would be a chemical change. Now that we've sorted out the difference between a chemical and a physical change, let's move on. Next we're on to organic chemistry. In organic chemistry, what we know is that any molecule must have a carbon. The key word here is carbon. If it has a carbon, then it is organic. It must have carbon to be organic. Okay, so let's sort out some of these examples and decide, is it organic or not. In this example, we see many carbons along the chain here. So this would be organic. This example also has carbon. You see carbon next to the hydrogens. So again, this example would be organic. Here we see carbon again in the center. This would also be an example of an organic molecule. In this example, enlarge it. As I look around everywhere, I don't see any examples of carbon. There are no examples of a capital C in this molecule. So this molecule would not be organic. Would not be organic. Let's try the next one. In this example, we have a carbon right in the center. So yes, this would be organic. And lastly, we come across the last one, and it again has carbon down the center. So yes, it would be organic. Now my question is asked of our mnemonic device we talked about in class, Chopkin's Cafe. Chopkin's Cafe tells us all of the elements that bond with carbon. Carbon, hydrogen, oxygen, phosphorus, potassium, iodine, nitrogen, sulfur, calcium, and iron. Chopkin's Cafe lets us know if we see an element, will it bond with carbon? If it has any of these letters in Chopkin's Cafe as the element, then yes, it will bond with carbon. So Chopkin's Cafe is our mnemonic device to say yes, it will bond with carbon. Okay, now we're going to talk about properties of metal. Properties of metals, we know that on the periodic table of elements, metals are on the left side of the periodic table. And the periodic table is made mostly of metals. The property metals have are luster, ductility, malleability, they're good conductors, and they have a high density. So let's look at some examples and decide what that means. Luster. Luster means that it is very shiny. So an example of something that is very shiny, an example of a shiny metal would be these. They would be a lustrous metal. The next word we have is ductile. Ductile means it is pulled into a wire. An example of a metal being pulled into a wire is this example. They are coils of metal, probably used in houses. Next, we have malleability. If it is malleable, it is bendable. And what bendable means is that you can bend it. The metal is bendable. Next, we have conductor. If it can conduct electricity. Here's an example of a switch plate that's possibly used in a computer or some electrical device. All of the wires you see on the switch plate are made of copper metal because they are good conductors of electricity. And lastly, we have high density. If it has a high density, it is a solid. All metals are solid except for mercury. Mercury is not. It's the only liquid metal we have. All the other metals are solids. So an example of a solid would be gold. It has a high density. Counting atoms. When we count atoms, we need to know a little vocabulary first. The first word I want to talk about is an element. An element is found on the periodic table, and the definition for an element is it is a pure substance. So an example I have here is molybdenum. Molybdenum is an element found on the periodic table. It is a pure substance. The next word I have for you is compound. A compound is a combination of elements. It is two or more elements chemically combined, such as in water. Water has hydrogen and oxygen. That is two or more elements chemically combined. And the last example I want to share is coefficient. Coefficient is the number that we see in front of a chemical reaction. A coefficient tells me how many molecules there are. The subscript is what is below or on the line next to the element. It tells us how many atoms there are. A subscript tells me atoms, and a coefficient tells me molecules. In this example, we have the reactants and the products of the chemical reaction. The coefficient would be 2, meaning you multiply the 2 times the coefficient 4, which would give me 4 hydrogens, as well as the oxygen has no coefficient, so it would only have 2 oxygen atoms. So let's check our work on the other side of the equation. 2 times 4 would 2 times 2 would give me 4, and 2 times 1, since there's no number, you assume it to be 1, would give me 2. So check, my math was done correct. And that was a short example of balancing an equation as well. So in my examples over here, we have ethane. Ethane has 2 carbon atoms and 6 hydrogen atoms. An example that might give you a little trouble is when we see parentheses. Parentheses, if you know the orders of operation in math, means whatever is outside of the parentheses, you do the same to all of the things inside. So I'm going to share this example of cupric nitrate with you. Cupric nitrate would have copper, which is a 1 because there's no number next to the copper, nitrogen, which is a 2 times 1 because there's no number next to the nitrogen, which would be 2, and oxygen would be 3 times 2, which would be 6. So in this molecule of cupric nitrate, you have 1 atom of copper, 2 atoms of nitrogen, and 6 atoms of oxygen.